Good morning. This is P. Venkata Mahesh, Assistant Professor in Mechanical Engineering Department, East of Aeronautical Engineering. Today we'll see we are going to start a new course called Applied Thermodynamics. This is for the fourth semester students of BTech Mechanical Engineering. This is the application of what we have studied in the third semester, that is thermodynamics. In third semester, we have studied thermodynamics, and here in this course, what we will do, how to apply the principles of thermodynamics in our real life. So we will see all applications in this course. So this the prerequisite for this course is that one must have studied the thermodynamics in third semester. Now the course is divided into 5 modules, and the first module will just have a brief introduction to IC engines. So what is IC engine? So engine is if I give some thermal input, I should get some mechanical output. That is an engine. Now we have 2 types of engines. One is internal combustion engine, IC engine, and the other one is external combustion engine, and that is EC engine. So the external combustion engine means the burning of the fuels and all take place outside the engine, and only will inject the steam into the engine. That is so the steam engines of the olden days, they come under the external combustion engine. Now the internal combustion engine means all our automobiles, they are classified into the IC engines. So the first module what we look into is what are different types of IC engines, and how the IC engines are classified based on the type of fuel we use, number of strokes are there, and based on the cooling system, based on the what type of ignition systems that are used, and what type of lubrication systems that are used in IC engines. All those things we will study in the first module. So you can see here, if I see briefly into the the topic, 4-stroke engines and 2-stroke engines. That is one type of classification of the IC engines. IC engine means internal combustion engine, and so the IC engines are classified into two types: the 4-stroke engine and 2-stroke engine. So and we'll see the further working of this 4-stroke engine and 2-stroke engines in further classes. The second classification is the SI engine and CA engine. So this is based on the ignition system. So how the ignition happens? This is SI means spark ignition engine, and this one CA means compression ignition engine. So in SI engine means the petrol is a typical example of SI engine. Petrol engine, all the petrol engines are the SI engines, and all the diesel engines are the compression ignition engines or CA engines. So here we'll see that the SI engine, after compression of the fluid, will ignite with a spark, and the fuel burns. So this the engine is classified as SI engine or spark ignition engine. And coming to the CA engine, what we'll do here is we have higher compression, and the fuel that we are using, diesel, is highly volatile. So what we'll do is, if just by injecting the fuel, we'll first compress the air and we'll inject the fuel inside the chamber. So with that, without any spark, the fuel will automatically get burnt. So this is called compression ignition engine. So then next one is valve timing diagram and port timing diagram. So what is the valve and what is a port? So the valve timing diagrams, they are in 4-stroke engines. in 4-stroke engines, typically we have two valves. One is inlet valve and the other one is outlet valve. So at what time the inlet valve should open and at what time the inlet valve should close, and at what time the outlet valve should open and at what time the outlet valve should be closed. So that precision in timing of opening the valves is done in valve timing diagrams. So we will see how to draw the valve timing diagram and what is the valve timing diagram, that we will see in the further classes. So the next one is the port timing diagram. So the port timing diagram is for 2-stroke engines, and here what we have is, instead of valves we have some ports. Ports is nothing but through which we allow the the air fuel mixture to come inside and the exhaust gases to go outside. We have two ports in that, and at what time the inlet valve, the inlet port should open, and at what time the exhaust port should be open and closed. So that timing is very much important. Otherwise, the combustion will not be proper, or the combustion, you can say the incomplete combustion may be there, and the exhaust gases will have the fuel particles, and that will cause a lot of problems for the humanity and as well as the nature. So the next one is a fuel injection system. So the fuel injection system, how will inject the fuel inside the IC engine. So in SI engine, as I already said, the fuel injection system will be before the engine. Okay. So in SI engine, what we are doing, the fuel is mixed with the air. The air and fuel is mixed outside the combustion chamber, and that mixture will be allowed into the SI engine, and after the compression, the spark valve will be ignited, and with that we will have the combustion process starting. But coming to the CA engine, here what we'll do, we'll allow the air separately, and after compression we'll inject the fuel inside the CA system. So the compression ignition system engines. So in this, how the fuel injection system should be designed for these two different types of engines, that we will see in this. And the cooling system. So as we know, with the combustion, there is a tremendous amount of heat that will be developed, that will be produced inside the engine. And if I'm not properly cooling the engine, what will happen is all the lubricant will get evaporated, and with that the engine performance will go down. So the cooling should be appropriately maintained. So in the two-wheeler automobiles, if you see, say suppose this is the engine. In two-wheeler, we have fins around the engine. So air will go across, and it is a air cooling system. The two-wheeler system is air cooling system. Coming to the four-wheeler system, we can have the water cooling system. So what we'll do here, we'll pass water through the lining of the cylinder, and that water will be again cooled. So this is the cooling system. So the cooling system is one of the vital part, you can say, for the IC engines. The next one is the lubrication system. So since the engine have the sliding parts, so this piston is sliding inside the the cylinder. The piston is sliding inside the cylinder. As there are two parts which are sliding against each other, we need lubrication system. Lubrication should be proper, and as well as along with that, we have the other the crankshafts and all those things. Everywhere, wherever there is two parts which are sliding against each other, we need lubrication, and how that lubrication is done in the IC engines, that we will see in the first module. So this is about the introduction to IC engines first module. Coming to the second module, in this module we'll see only how the combustion happens, various aspects of combustion in SA engine as well as in the CA engine. So in combustion, so what normal combustion? Normal combustion means the combustion process is done perfectly. Okay, if the combustion is done perfectly, then it is called normal combustion. And the abnormal combustion means if the combustion, is done. Say suppose if I inject less fuel than required, the combustion will not be proper. And if you inject more fuel than required, then also the combustion, the exhaust will have the fuel particles. So that is called the abnormal combustion. Okay. So the normal combustion means adequate amount of fuel is injected and all the fuel particles are converted into the carbon dioxide and water vapor. So that is the case where it is called as the normal combustion, and if it is not done properly, then it is called the abnormal combustion. This we will see in the second module. And the importance of the flame speed. Flame speed. Say suppose I start my combustion at the inlet, okay, and at the top of the cylinder. So this combustion flame here, as the combustion initiated here, the flame should propagate through the cylinder. If it propagates through the cylinder properly, then the combustion will be proper. So that is called the flame speed. At what speed the flame is going forward. And if my cooling is not proper, what will happen is the the other parts of the cylinder, the engine, there can ignite some the fuel mixture, and it can also cause some abnormal effects. So the flame speed, how the flame is propagating from the from the point of initiation of the spark to the end. So that is the flame speed. So the next one is effect of engine variables. Okay, effect of engine variables. And then the next one is types of abnormal combustion. So the types of abnormal combustion, we have two things. One is pre-ignition and another one is knocking. Pre-ignition means, as I said, if cooling is not proper, before I ignite in SA engine, generally it will happen. Before I ignite the spark, because the temperatures at a particular point is more than what it should be, what happens is the fuel get ignited at that point, and it will propagate in a wrong direction. It will propagate so that is called the pre-ignition. So before the time I want the ignition to start, the ignition starts because of the failure of the lubrication, the cooling system. The cooling system, if it fails, what happens is the pre-ignition can happen. And similarly, we have knocking also, and we have the fuel requirements and fuel rating. Fuel requirements means what is the amount of fuel required for the amount of the air that we are taking in. And fuel rating that also we will see. And anti-knocking additives. So if I want to avoid the knocking, what are the additives I have, what are the materials that I have to add so that the knocking can be prevented. So that is one part. The second part is in CA engines. In CA engines, how the combustion happens. In CA engines, 4 stage of combustion. See here also, in SA engines also, the 4 stages of combustion will be there, and here also in CA engines also the 4 stages of combustion will be there. So, and delay period, its importance, effect of engine variables, diesel knock. So knocking can happen in SI engines and CA engines, but pre-ignition happens only in SI engines. Okay, because here in CA engines we are injecting fuel after the completion of the combustion, but in SI engines the air fuel mixture is supplied. So before the combustion process completes, the ignition can happen because of the hot spots that are there inside the cylinder. So this is what we will see in module 2. Coming to module 3, we have two things here. What we have done in module 1 and 2 is how the engine works. Okay, so in the third module we'll start with seeing the performance of the engines. What is the amount of will take an engine, what is the amount of fuel supplied, and what is the amount of power produced. That balance sheet will make in this third unit. So the measurement of cylinder pressure. So what is the pressure developed inside the cylinder, that also we will see. What is the fuel consumption, what is the amount of fuel consumed during the combustion process, that we'll study here. Air intake, how much air is supplied. Exhaust gas composition. So if the combustion is normal, what happens is the exhaust gases will have only carbon dioxide and water vapor. If the combustion is not proper, what I can have is carbon monoxide, and sometimes because of the fuel we can have nitrogen also inside the combustion exhaust gases. And what is the brake power, how much power is developed at the brake end. Okay, we have one is engine end and then one is the brake end, or where the wheels are connected. So at that junction, what is the power that is produced. And determination of friction losses. So as I said, there are sliding parts inside this IC engine. What will happen is, because to avoid this friction, we have to to overcome this friction, we have to spend some power that is produced inside this, and that power is called the frictional losses. And the indicated power and performance test and heat balance sheet. Heat balance sheet means how much water heat is taken away by the cooling system, and how much heat is taken away by the exhaust gases, how much heat is produced by the combustion. That balance sheet will put. So these are the various aspects that we will see in the module 3. And coming to the classification of compressors. So the compressors, we have two types basically. One is the positive displacement compressors, and the other one is rotodynamic compressors. So positive displacement compressors and rotodynamic compressors. So this classification is very important. Many people, they will positive displacement means reciprocating compressor, they will say. But what is positive displacement means, if say suppose I have taken air from the suction, okay, and I am after compression I am delivering to the delivery valve. So if there is no chance for the air which is getting compressed in the compressor to go back into the suction line, then it is called a positive displacement pump. So positive displacement pump is the movement of the air inside the compressor is only in positive direction. There is no chance of going leakage inside in the positive displacement pumps. So the other one is rotodynamic pumps. So the rotodynamic pumps are centrifugal pump or axial pump. They are called rotodynamic pumps. So in rotodynamic pumps, what happens is, I have my impeller rotating like this, and there should be some gap between the casing which is enclosing the impeller and the impeller. So between this impeller and the casing there should be some fine gap, and so there is a chance of the air that go back to the inlet through this gap. So it cannot be called as the positive displacement pump. Then why they are called the, how the pressure is built inside the rotodynamic pumps. So say suppose if I take the centrifugal pump. So this is the centrifugal pump. I will write here. So this is the inlet and I have the centrifugal pump like this. Okay, impeller. This is impeller. So what happens is, as this rotates, what happens here, whatever air is there, it will be dispelled outwards. So when the air is dispelled outwards, what happens here, there will be some vacuum created at this eye. So because of that, it will suck air from the inlet, and all this pressure building is happening because of the rotation of the impeller. It is called the rotodynamic pumps. So we'll see brief classification of these compressors, how they, based on the positive displacement, how the displacement happens, and based on the how the pressure is built inside the compressor. That we'll see in the third module. Coming to the fourth module. The fourth module will detail study about the, as what is this classification? They are rotodynamic pumps. The centrifugal pump and the compressor and the axial compressor, they comes under the rotodynamic pump. So from here to here it is a axial flow compressor, and from here to here it is a centrifugal compressor. So the centrifugal compressor, as I already have shown previously, so it is like this. So the air enters radially and leaves radially almost. So that is the centrifugal compressor. So it's coming to the axial compressor, the vanes, the impeller will be like this. So here also one impeller will be there. So the air will go in this direction. Okay. So the as axial to the shaft, the air will go. So they are called axial flow compressors. So centrifugal compressors, what we will see is mechanical details. What are the different parts that are there inside a centrifugal compressor? And what is the principle of operation? How that works? How the pressure is built inside the compressor, centrifugal compressor, that we will see. And velocity and pressure variation. How the velocity changes from inlet or the suction to the delivery of the compressor, that we will see in velocity variation. How the pressure increases as it goes from inlet to outlet, that we will see. And the energy transfer, how the energy is getting transferred from the impeller to the fluid, that we will see. And impeller blade shape losses. So the impeller blade shape can be forward, backward and radial. So it can be like this, or it can be like this. So, or it can be radial, straight veins. So the impeller blade shapes, how the impeller blade shape will be there. Next one is, what are the different losses? The leakage losses, the slip losses, all those losses are there. And what are the losses that are there in centrifugal compressor? And what is the slip factor? Okay. And what is the power input factor? How much power it should be actually supplied, and because of the losses, how much extra power is getting supplied. So what is the pressure coefficient? So how much, it is the ratio of the outlet to inlet pressure. So how that pressure, what is the pressure coefficient, and what is the adiabatic coefficient? Adiabatic coefficient we'll see, and we'll see the velocity diagrams. So velocity diagrams means there are two types of velocities here. One is absolute velocity and the other one is relative velocity, and as well as the blade velocity also comes in picture. So using these velocities, we'll build a triangle which is called the velocity triangle, and that velocity triangles will be discussing in velocity diagrams. And what is the power that is consumed inside the compressor, that also we'll discuss. Then later part we'll see what is axial flow compressor. In axial flow compressor also we have many parts. We'll see that in the mechanical aspects, and again we'll see the operation, how that actually functions. Okay, here I said where here suction will be there, and here because of that suction the air will be sucked inside and it will be dispelled outside because of the centrifugal force. So that is the function principle of centrifugal compressor. Similarly, we have the axial flow compressor also working with some principle that we will see. And here also again we have the velocity triangles that we have to draw between the absolute velocity, the relative velocity, and the blade velocity. And again we will see the energy transfer per stage of reaction. So here this is important. So per stage of reaction means here in axial flow compressor what we need is we need a series of blades like this. Okay, so this is a series of blades. One blade row is not sufficient. We need series of blades, and in this series of blades one set is a stationary blade, the other one is the rotating blade. So this and that one set of rotational stationary blade is called a stage, and for each stage what is the pressure, how much pressure is built, so that we'll see in the stage degree of reaction. And work done factor, how much work is how much pressure is built, for that how much work is inputted, that we'll see. And what is isentropic efficiency? So isentropic efficiency means the compressor is supposed to work under as isentropic process, but because of the friction losses and all, it will not go along the isometric path. So this deviation from the isometric path will give the isentropic efficiency. Isentropic efficiency means if it actually if it follows the isentropic path, we need less compression work. Okay, less work for compression. Say suppose this is the low pressure line and this is high pressure line. So if it goes along the isentropic path, we need less work, but it is deviating from the isometric path. Because of that we need more work to be spent. So that is called the isentropic efficiency. The actual work, the isentropic work to the actual work will give the isentropic efficiency. And pressure rise calculations, how the pressure is rising from each blade row, that we'll see. And the other one is polytropic efficiency, so that also we'll see. So the last module we have the refrigeration. So refrigeration means we want to keep the elements inside in a room. Say suppose this is a room, and this room should be kept cooler than the outside atmosphere. So say if I am talking about the things inside this room, then it is called the refrigeration. If I am talking about the human comfort as well as the things inside the room, then it comes under the air conditioning system. So the air conditioning system and refrigeration system, the differentiating factor is the human comfort. So the refrigeration is done for the element, the things, matter. So I want to keep my food material cooler than the outside, or I want to keep my my laptop or something should be cool. I want to keep, say suppose I have a big, if the humidity factor is not going to affect the things that are there inside, then we will talk only about the refrigeration. How I'm trying to keep the things inside the room cooler than the things outside the room. And how we are doing that? We are trying to send the heat inside the room to outside. So the inside room we have lesser temperature, still we are taking heat from that and supplying to the rejecting to the outside environment. So that is the refrigeration. So in this refrigeration, what are the mechanical refrigeration and type? What is mechanical refrigeration and what are the types? What are different types of refrigerations we'll see. And what is the unit? Says just like the meter is the unit for distance, we have a unit for refrigeration also. That what is that unit of refrigeration, that we'll see. And air refrigeration system. So air refrigeration system means we use only air inside the entire process inside the circuit is done using air. And with that, how much refrigeration we can develop, how, what are the details, what are the different parts of the air refrigeration system, and how that air refrigeration system is giving that refrigeration effect, what is the principle of operation, that, and what are the applications of air refrigeration system, that we'll see. And then the second part we'll see vapor compression refrigeration system. Say suppose if I replace this air with vapor, okay, if I replace this air with vapor, then it becomes the vapor compression refrigeration system. And how this vapor compression refrigeration system works, and what are the different parts inside the vapor compression refrigeration system, and what is the principle of working of that. And then we will see how, what is the coefficient of performance. So the coefficient of performance means we are giving some mechanical input and we are producing some cooling effect. So the cooling effect divided by the work input gives me the coefficient of performance. So the coefficient of performance, how the air refrigeration system, what is the coefficient of performance of the given air refrigeration system for the given temperature conditions, and what is the coefficient of performance of the vapor compression system for the given temperature conditions, that also we will see in this unit. So next we will see what is the effect of superheating, subcooling. So superheating means if, say suppose this is my diagram, this is the TS diagram, entropy, and this is my curve. Say so if I, and this line is the saturated vapor line and this line is the saturated liquid line. So if I am heating the vapor beyond the saturated line, then it is called the superheating of the vapor. So the already it is vapor, I am trying to put more and more heat into it, what it becomes is called superheat vapor. And the other one is subcooling. Subcooling. So already here it is liquid. If I further decrease the temperature, it becomes subcooled. Okay. The liquid is already at this point, it is saturated liquid line. So at this point, it is becoming liquid. If I am trying to reduce the temperature further, it will become the subcool. Now, what is the effect of superheating the vapor, or what is the effect of subcooling the liquid? So on the performance of the vapor compression refrigeration system, that also we will see. And what are the desired properties of the refrigerant? Refrigerant means whatever fluid, whatever vapor we are using inside the vapor compression refrigeration system is called refrigerant. Okay. What are the common refrigerants that we use, and what are the properties that are desired for the refrigerant so that it can be used as a refrigerant? What are the properties desired for any particular fluid to be used as a refrigerant? That also we will see. And then we will see the pH charts, the pressure versus enthalpy charts for and calculate the performance of the vapor compression refrigeration system. So this is the fifth module. This is the final module. These are the 5 modules that we are going to discuss in this course. And here are some textbooks that I am going to refer, and there are some other textbooks. If I refer for any particular topic, I will tell that name of the textbook for that particular topic. And in general, I am going to refer these textbooks for the course. So the textbooks are IC Engines by Ganeshan by Tata McGraw-Hill, and IC Engines Fundamentals by John Haywood, that is also of Tata McGraw-Hill. And there are 2 textbooks, Thermal Engineering and Applied Thermodynamics by Rajput in Lakshmi Publications, and other one is Engineering Thermodynamics. This already we have used in Engineering Thermodynamics. That also we will see for any basics I want to refer. I will go back to Thermodynamics textbook. And the other one is Mathur and Sharma for IC Engines, and Engineering Fundamentals of IC Engines by Palbrack, and that is a Pearson edition. And Rudramurthy is Thermal Engineering by Rudramurthy. Sometimes I may refer this one also. And the last unit I am going to refer Refrigeration, CP Arora, Refrigeration and Air Conditioning by CP Arora and Arora Domkundwar. Some other textbooks I may refer for different problems if I want to solve, and that also I will tell. And Engineering Thermodynamics by Jones and Durgan. So this either I use this textbook or PK Nog for the fundamentals which I want to refer back. And the Applied Thermodynamic textbooks I will refer mainly for this course. So if I want to recap, so what are the different modules? One is IC engine module, and second module is combustion in IC engines, and third module is performance of IC engines, and as well as introduction to compressors. Fourth one is performance of different compressors, and fifth one is refrigeration, introduction to refrigeration. Actually, refrigeration and air conditioning is a huge subject, and that will be dealt with in the another video series called Refrigeration and Air Conditioning series. That will be for final year BTech students, and here we will just give some introduction to the aspects of refrigeration. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.